So today's podcast deals with solving math equations using significant figures. And I'm assuming that you either understand how to use significant figures, and if you don't, you can go back and watch this podcast on significant figures. And if you recall, as a quick review, for significant figures, it's all about the zeros. So, what kind of zeros are there in numbers? Well, there's leading zeros. Zeros that are in front of a number, like 0.001. There's captive zeros that are in the middle of a number, like 101 Dalmatians. And there's trailing zeros, like I teach about 100 students, or I teach 100 students exactly. Now, what was the deal with the zeros? The zeros in front, leading zeros, never count. So you take your pencil and you put your pencil down and you cross these zeros out. And so therefore, the only number that means something is this one. And therefore, in this number, there's only one significant figure. Captive zeros always count. And so you pick up your pencil and you put underneath the first number that you find. You continue drawing past that zero until the last number that means something. And in this case, there are three numbers that mean something. So there are a total of three significant figures. Trailing zeros only count when there's a decimal. Is there a decimal here? If I teach around 100 students, that means I could teach anywhere from 52 students to 140 students. So guess what? Those zeros don't mean anything. So if there's not a decimal, you pick your pencil up and you cross them out this way. So how many significant figures are there in this number? 1. All right. What about this number over here? This number, sorry, let me fix this for you so you can see very clearly. This number does have a decimal. Look at that. There is a decimal there. And so therefore, all three of these zeros do count, or excuse me, all three of these numbers do count, the zeros included. So there are three significant figures here. If you do not understand significant figures, then you need to go back and look at the video on significant figures. It's that easy. Don't make it harder, okay? So, what do significant figures have to do with anyway? Well, the bottom line is if I was to measure this line right here, this line, if I measured it with this ruler, I'd be guesstimating how long it would be. It depends. I mean, if I'm just cutting you a piece of string because you say, hey, I need a little piece of string, then there's your little piece of string. But what if I'm using this piece of string to use it, I don't know, to make something, and I need exact measurements? Well, this is more exact, isn't it? So we'll label these A, B, and C. Which one's more exact? Which one is not as uncertain? If you said C, you're correct. There's a lot of uncertainty in A, and there's a lot of much more certainty in C. And there's different times in your lives when you need to be certain and not. Which one, A, B, or C, would you rather have them using at the Tylenol factory that makes your Tylenol? I sure would like them to use C, to actually measure things to a degree of certainty and not just put, you know, about this much into the Tylenol. What's a pinch of salt? Well, a pinch of salt could be A. Doesn't really matter, does it? Okay, and so in the significant figure video, I went into the fact that if I was going to make kitchen cabinets and put kitchen cabinets into a space, you'd have to measure, definitely, and you'd have to be careful about what kind of room you're putting them in. But if you looked at these kitchen cabinets right here, okay, yeah, I'd have to measure this room, but I could put whatever kind of kitchen cabinets I want to in here. I could put different colors, different sizes. The layout would have to fit my kitchen, and I have to be pretty exact in my measurements. But what would the exactness have to be compared to planning for the Orion mission to Mars? There's quite a bit more exactness that's included, and there's more error for measurement when I take some people on a trip to Mars. So that's the difference, and when you need to know how to use significant figures. So the bottom line as to why this is important is because of your safety. But when you're doing measurements and you actually do math with them, if there's errors, they can compound. So we're going to learn rules today. There's two different segments of math equations you can do. You can add, subtract, or you can multiply and divide. And right now we're going to talk about adding and subtracting. I'm going to do a couple examples, and then we're going to go ahead and go over to multiplying and dividing, and then I'll combine them. So when you first learn how to add and subtract, you lined up your decimals. That's what you're going to do. So to do this, when I add and subtract using significant figures, I got 4 choices over here. A, B, C, and D as to what the right answers are. And you may or may not say, depending on the rounding rules your teacher gives you, what those answers are. So using significant figures, you're going to line your decimals up. You're going to look at the number that has the least decimal places, and look, this has only 4 decimal places, doesn't it? It stops at the hundredths place. This number, on the other hand, stops at the thousandths place. So I'm going to pick the number that has the least amount of places, and to do that, I'm going to drop a line. You see what I just did? I just dropped a line next to the 7 because it had the least amount of places. Now I'm going to go ahead and add. And when I add, I get 6, carry the 1, 5, I get 15.506. So, what's the right answer? Well, guys, you are limited by the least amount of places, and the least amount of places is this place right here. So you go ahead and this is your answer. However, you have to ask yourself, what does the 6 do to the 0? If you said it rounds up, you are correct. And so therefore, my correct answer choice would be C. Because it's 15.50, but the 6 rounds that 0 up to 1. And therefore, that's my correct answer. Let's try another example. So using your rounding rules, using your rules for how you add and subtract, I'm going to drop a line right here, correct? Okay. Then I'm going to go ahead and add. And there's a 2, and a 6, carry the 1. Okay. Oh, I'm subtracting here. I'm sorry. That would make a difference, wouldn't it? Whoops. Okay, so let's subtract. Sorry. There's a 4 and there's a 3. Okay, and on your calculator, let's see if you can figure out, or just in your brain, let's see if you can figure out what the answer is going to be before I write it up here, based on exactly what we did on the last screen. Okay, so this is 11. All right, what's going to happen? I'm going to box this part of my number, because this is what my numbers mean. That's my significance. I'm going to ask myself, what's the 2 do to the 4? There's absolutely nothing. And so the answer is B in this case. All right? All right, now, you can pause this if you'd like. Let's go ahead and let's do this math here. All right? And you're going to figure out what these are and how you do the significant figures with them. Think about what you do. Okay, and I'll go ahead and do it. If you want to watch me, you can. If not, pause it. I'm going to draw my lines right here for all of these because I'm adding and subtracting. Now, what's my answer for this one? My answer for this one is, whoops, well, I'll just leave it. 15.675. Okay, and I'm going to go ahead and put the answers down, and you figure out what the right answers are. Okay. And then what do you get from this one? I haven't forgotten you, don't worry. Alrighty. So, I've subtracted the way you normally subtract, or added the way you normally add, but now we're going to go ahead and we're going to box our answers. That's what my answer should be, that's what my answer should be, that's what my answer should be, and this is what my answer should be. But now what do you have to ask yourself? What's the 5 do to the 7 here? Does it round it up? If you said yes, you are correct. So I'm not going to list the 5. I'm going to change this to an 8. the 5 turns that 7 into an 8. So my correct answer for this one is 15.68. What's the 2 do to the 4 in this situation? Nothing. And so my answer remains 15.74. Coming over to this example over here, what happens? Does a 7 do something to the 5? Yes, it does. It rounds it up to a 6, and so my answer is 1.46. And what's my 2 do to my 5 in this situation? Nothing. And so my answer is 1.45. All right, let's move on and look at multiplying and dividing, because there's completely different rules for multiplying and dividing. And this is where it's important that you know your significant figure rules, because if you don't, then you can't do this correctly. So before we do any multiplying and dividing, we're going to look at each of these and see how many significant figures there are. How many significant figures are here? Both of those are significant, aren't they? Yes, because they're numbers and they mean something. What kind of zero is here? If you said trailing, you're correct. Is there a decimal? Yes. And so there's 2 significant figures here. If there's 2 significant figures here and 2 significant figures here, then I need to have 2 significant figures in my answer. Okay? So I'm going to go ahead and do each problem by itself, and then I'm going to go ahead, or in groups, and then I'm going to go ahead and erase them so you can actually see, and this board isn't filled with stuff. Okay, so if you multiply 2.0 times 3.8, you're going to get 7.6. Now, how many significant figures are in the number 7.6? If you said 2, you're correct, and therefore that is your answer when you multiply these two numbers. Now, if you look at the example right below, 2.00 times 3.8, and I'll go ahead and use, I guess I'll use green here, okay? How many significant figures are here? If you said 2, you're correct. How many significant figures are here? Well, those are trailing decimals, or there's trailing zeros and there's a decimal. So therefore, there's 3 significant figures. Now, which is the least of the significant figures? There's 2 here, and there's 3 here. So my least amount is 2. So my answer is going to be in 2. And therefore, this lovely lime green 7.6 is going to be the same. My answer is only as accurate as my least accurate amount. My 3.8 limits me from reporting it to 3 decimal places. So the answer for both of these is 7.6. All right, let's look at this next example here. So that was a 5 that I had there. Whoops. Okay. Pen, come on, there you go. All right. So 5.6 times 4.12. How many significant figures are here? There's 3. How many are here? 2. So when you multiply your answer, or your numbers to get your answer, 5.6 times 4.12, you get 23.072. Now, with numbers like 3 significant figures and 2 significant figures, you cannot report a number to that amount of detail. Cannot. What limits you? Your 2. So you're going to come and look at this 23.072 number, and you're going to say, okay, there's a number that means something, there's a number that means something. I'm going to stop, and now I have to ask myself, does a 0 do anything to that? No, it does not. So my answer is 23. And that's how that works. Knowing that, dividing is the exact opposite of multiplying. And so therefore over here, if you look at my answers, what will my answers be for these? So if you look, 4.2, I've got 2 significant figures here. And for here, I have 3 significant figures. For this one, I have 2. I was looking at this 8, and I only have 1 here. So what's my answer have to be limited to in this case, guys? 2 significant figures. But this one, I can only report my answer to 1 significant figure. So if I do my math and take 4.2 divided by 8.22, I get a ridiculous number of 0.5109489,051. And so in the past, you and I have agreed to round to the hundredths place. But now you know. You can only round this to two significant figures. So let's look at that. I have a 0.51, okay? What's the 0 do to that? Nothing. So all these numbers don't mean anything, and my answer is 0.51. So now let's look at my next example, 4.2 divided by 8, and my answer would be 0.525. I am limited, however, because of my significant figures, to only one decimal place. So I'm going to come over here, I'm going to look at my numbers, I'm going to say 0.5. Does the 2 do anything to it? No, it does not, and so therefore my answer is 0.5. All right, if you need more practice, here's some, and then I'll go ahead and do a mix-up. You can pause it if you want to, and here goes if not. There's two significant figures here, and there's three significant figures here. So my answer has to have two sig figs. When I multiply, I get 3.74. Limited by 2, I only can use it as 3.7. The 4 does nothing to it, so my answer is 3.7. If I take 10.8 and divide it by 7.3, I get 1.479452055. And there's no way in the world that I can report this number to this degree of precision and accuracy because I have three significant figures here and only two here. So I am limited in my answer to two significant figures. So I come over here and I say, how many significant figures are here? Okay, there's a 1 and a 4. All right, I'm trying to get a different color there. There's 1.4, that's two significant figures. What's the 7 do to it? Ah, now it rounds it, doesn't it? Okay, so my two significant figures makes my answer 1.5. All right, now, if you'd like to pause this page, you can. If not, you can go ahead and follow along with me and make sure you understand. But you need to be able to do this by yourself. When do you draw your lines? Only when you add and subtract, correct? When do you do significant figures? When you multiply and divide. Here I have 2, and here I have more, right? Don't I have more here? Yeah, I have 4, but the bottom line is I have more, so who cares? My 2 limits me. Taking that in mind, what do I have here? I have 2 here, don't I? What do I have here? More. So do you need to count them? No, I don't. My 2 limits me. How many do I have here? I have 3. How many do I have here? More. So bottom line, what am I looking at? 3 for my answer. Okay? So if I add these up for this top one, I get 6.24. That 4 does not round it, and so therefore my answer is 6.2. What happens when I add these up? My answer is 6.245. That's what I'm limited by, and what does my 5 do? It does round up that 4, doesn't it? And so my answer would be 6.25, not 6.24, because the 5 rounds that 4 up. If I subtract these, I'm going to get 3.8165. This is what my answer has to be in. However, that 5 rounds to 6. So what's my answer going to be reported as? 3.817, because the 5 rounds that 6 and changes it to a 7. Coming down here to multiplying and dividing, I do not look at drawing a line, do I? I look at my significant figures, and when I multiply this out, I get an answer of 6.024. However, as you recall, I'm limited by 2 significant figures. So I have to look at that 6.0 and say, does the 2 do anything to the 0? And I say, no, it doesn't, and so therefore there's my answer. I'm going to multiply 4.8 times 2.000, and I get an answer of 9.6. How many significant figures do I have? 2, and therefore 9.6 is my answer. Now, it's been a while since you've seen perhaps division set up like this, but 4.11 is going to be divided into 3.902, and I get the ridiculous number of 0.94939177275. There's no way in the world that I can report it to that degree of precision or accuracy or detail, and so therefore I look at my significant figures, and I'm limited by this 3. So I look here and I say, where's the numbers that mean something? Oh, look, there's a 9, a 4, and a 9. Does a 3 do anything to that? No, it does not. And so therefore, my answer is 0.949. If you need to watch this again, you can. Good luck doing your work on significant figures.